Okay, so remember we were asked to find BC correct to 1 decimal place. So BC is this length here. So BC. Now we figured out in the last slide that angle X was 116.42 degrees. So angle X is 116.42 degrees. Now we need to find angle Y, and that will help us find angle Z. So we're going to take the triangle ACP. So ACP. So this angle here on the left that contains angle Y. So we're going to do the same as before. We're going to label our triangle A, B and C using the cosine rule. Remember that we have a capital A in our formula, so the angle that we're using or looking for has to be labelled as angle A. So angle Y is now labelled as angle A, and the opposite side to that is lowercase a. So the B and the C don't matter. So since this is already labelled as angle C, we're going to call this lowercase c. So therefore this becomes angle B, and this becomes lowercase b. So anything done in red is this first part here. I've done them in 2 separate colours so it doesn't get too confusing. Okay, so we've labelled our triangle, so now we just have to substitute our values into our cosine rule formula. So the a squared is 38 squared, the b squared is 20 squared, c squared is 20 squared, minus 2bc becomes minus 2 times 20 times 20, and this time cos of a becomes cos of y. So similar to what happened in the last slide, we're going to rearrange so that cos of y is on its own. So the 38 comes over the equal sign, becomes minus 38 squared. And we still have the plus 20 squared plus 20 squared. Then the minus 2 times 20 times 20 cos of y goes over the equal sign and becomes positive 2 times 20 times 20 cos of y. And then we divide across by the positive 2 times 20 times 20 to get the cos of y on its own. We put all this into the calculator and we get minus 0.805, and then we use the inverse function to get angle y, so cos to the power of minus 1, and it gives us 143.61 degrees. So angle y is 143.61 degrees. Now to find angle z, we're going to take 116.42, which is angle x, and 143.61, which is angle y, away from 360 degrees, because the angles in a circle add up to 360 degrees. So 360 minus 116.42 minus 143.61 is 99.97 degrees. So angle Z is 99.97 degrees. Now we can use this and the other values that we have to find the side BC. So that's why I've labelled this as X. This is ultimately what we're looking for. So again, we use the cosine rule, and this time the values I'm using I've labelled in green. So for this formula I'm using the green values. So I this time know what my angle is. My angle is 99.97 degrees. And I'm going to substitute that into the formula to find the unknown side. So the angle Z, which is 99.97 degrees, has to be labelled as capital A. So the opposite side is lowercase a. Since this is angle B, this is going to be lowercase b. Since this is angle C, this is going to be lowercase c. Put it into my formula. A squared now becomes BC squared. That's what we're looking for. B squared is 20 squared, C squared is 20 squared. Minus 2bc is minus 2 by 20 by 20. And cos of A is now cos of 99.97 degrees. So I can put this straight into the calculator, and it gives me 938.51. And then I get the square root of that to give me 30.6 meters. So my missing side BC is 30.6 meters. And this is to 1 decimal place. Remember, we are asked for 1 decimal place. Now, very important. Why did I use the cosine rule each time? Well, for example, in the top triangle, I was given a side, another side, and a third side. So I had 3 sides and I was looking for one of the angles in between. So that is one time when you would use the cosine rule, definitely, when you have all three sides and you're looking for an unknown angle. In the other triangle, I had a side and I had another side, and I had the angle in between the two of them. So I had a side, an angle in between, and a side. And I was looking for the opposite side to the angle that I had. So that's another time when you would use the cosine rule. I use the sine rule, however, when I have a side and its opposite angle.